one is Unpacking, PMA 102. And so for this one, you need the malware samples. And if you're using the machine that I gave you, they should be on your desktop. If not, they're pretty easy to obtain. Why is pressing enter not letting me out of here? All right. All right. So the malware samples are here in this folder on the desktop. So first we're going to look at strings. We're going to use bin text. Now we just looked at strings in Process Explorer, which is one way to do it, but there's a McAfee application here, bin text, designed just for this purpose. And this is good. This is why I turned off VMware Tools, so I could make this big. All right, let's see if I can get this thing to go away. Good, all right. So I want to examine lab0102.exe. So I browse into that folder, chapter 1, lab0102.exe. All right, and then go. All right, every program always starts with this. This program cannot be run in DOS mode. And then you have something called mal service, which kind of suggests that might be some service created by this malware. Then you have the start of a URL, but it's missing. It has a W and then it stops. Then there's some junk here, like that might be a .com, but maybe not. This is kind of funny looking. And there's really not very many strings. You know, for comparison, let's take a look at that 99 bottles we just wrote in the previous project, C99, 99.exe. If you look at the strings here, it always starts with this program, but then it's got text and our data. And remember, it has, here's the 99 bottles stuff that we typed in. And then it's got a lot of stuff, like the days of the month and days of the week and months of the year and all the languages and all this fancy stuff. There's a lot of stuff in there. But this malware sample has almost nothing in it. All right, so let's take a look at it with PEID. And I think I'm going to continue this trend. I'm going to start by looking at the 99 bottles. PEID is a program just to identify what language something is written in. And again, it's set here so it will get nice and big. All right. So if I open the 99 bottles of beer thing in PEID, it tells me, thought it would tell me it was made in Visual C++, but apparently not. However, if I look at the sections, I will see the normal sections, .text, .rdata, .data, and .relocation. Those are normal. That's what you'll almost always see. But if I look at that malware sample, which is Desktop, Practical Malware Binary, Chapter 1, Labo102, again, it cannot identify the language, and the sections don't have the normal name, UPX0, UPX1, and UPX2. These are not the normal sections. There should be a .text section for the run executable code, and then a .data section. Instead, there's this junk. So this is the sign of the UPX packer. Now you can also examine it with PEView. And PEView is designed just to show you how these programs work. So if I open Labo102, you will see in raw hexadecimal, here's the structure of the program. They always start with MZ. They always have this program cannot be run in DOS mode. That's the image DOS header, which is a useless appendix, the MS-DOS stub program. Then starts the real header, the image NT header, starting with PE. This is the modern portable executable header. And you have various things here like an entry point. Here's the address of the entry point, and so on. And let me see, I want to see the sections down here. See them UPX0, UPX1, and UPX2. Those are those funny named sections. Now we can look at the import directory, which is here. These are all the library functions it's going to use. And seeing kernel32.dil, advanced API 32, and a couple of others, only a few library functions, a very small list. All right. And so that's what you're seeing is just the unpacker. This program is packed, and it has to unpack to load it. And if you want to see the specific API calls it makes, the functions it calls, you can see them here in the address table. Load library, get process address, virtual project from kernel32, nothing here but create service, nothing here but exit, and one function from here. You can also see the same information in CFF Explorer. you can actually do it here. CFF Explorer is another tool that lets you see the structure of a Windows executable file. And it's on the desktop here, 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 and here. All right. And I think I can zoom in like this and it will work. Maybe not. I think students have told me this does work. Is it getting bigger? I think they've told me it is getting bigger. I can no longer see the chat window. But anyway, here you can go to the import directory and it will show you again how many functions are being loaded from each library, like kernel32.dil, and down here it will show it to you, load library A, and get process address and virtual protect and virtual allocation. So this tool is another tool that shows you what's in there. Yeah, good, it does get bigger. Thank you. That's what I thought. So I can do that when necessary to make it easier to see. Anyway, now we're going to unpack the file with UPX. So we just need a command prompt in that folder, and you could do it by CD, but the easy way is in Windows 10 is open the folder until you get to where the file is, and then go here and open a command window there. And I can open PowerShell. It's as good as CMD. That gets me a window that's already in the right location. And I can make the font bigger. All right, so now I can do a dir, and I will see that there is a Lab 0102 here that is 3,000 bytes in size. And I can run UPX. UPX is already installed on this machine, so when you run it, it shows you this is the ultimate packer for executable, and you can decompress with -D. And when you do that, you tell it where to put it with -O. So that's really all I need. I can do UPX, decompress, put the output in lab 0102 unpacked.exe and read the input from lab 0102. That should do it. And it did do it. It inflated it from 3K up to 16K. So now I'm going to have a new program here called Unpacked, which is much bigger. And now if I examine that pack, I'm going to find it looks very different. So let's take a look at it in, for example, PEID. All right. And if I go here and I load the unpacked one, now it detects that it's Microsoft Visual C++. And now it has the usual sections, text, RData, and data. Doesn't just have UPX0, UPX1. So the unpacked code is better, and that would mean that the strings are going to be more visible. But let's just take a look at PE view as the next thing to try. The unpacked file here is now a normal file. And so if you go to the image NT headers and the image optional header, now the image base is 400,000, and that's normal. And here's the text, RData, and data section. And if you go in the RData and look at the import address table, it's now using a lot more libraries, a lot more functions in each library. So this is the real program doing what it really does. And therefore, we should be able to see strings in here. So let's use bin text. And we should see much better strings than the ones that were all broken up before by the packer. So let's get rid of this and go to the unpacked file in desktop. There. And go. And now you see libraries here, and you see some API calls like create mutex, and then you see a complete URL, www.malwareanalysisbook.com. This is the URL that was broken up before. And you see more things in here that are interesting. Like, I think, yeah, down here you see that again, version of IE, open a URL. Anyway, you can get some idea what it does now, and you can get indicators of compromise like this That is a URL referred to by the file, so that might be a command and control server or a staging server where it loads another stage of malware or something. That's valuable information, which was concealed by the packer, and that's why bad guys use packers. All right. So I think that's all I wanted to show you today. I'll stop this one.